Okay, this is part 2 of experiment D3, and in part 2 you have to build upon part 1. So just to remind ourselves of part 1 again, in part 1 you had to build a one word by 4-bit memory module using the 7475 D-type latch, and that was the arrangement there. So in part 2 then you have to build upon that to extend to a 2-word by 4-bit RAM module. Okay, and this is the circuit here, as you can see in this fig 2, and you can see here that we have two 7475 quad latches. Okay, and we'll call this one latch 0 and this one as latch 1. So we're building upon part 1, and the problem that arises from using two latches in this configuration is that you need to design an address decoder which will control when we read and write to both of those latches. So what we're going to do is to write 1001 to latch 0 and 0011 to latch 1. And the functionality is determined by this table here, table 1. So for example, when A0 is 0 and the RW bar line is 0, that means we are writing to device 0, which is this latch here. Okay, and that's why the enable line is high there. And if we want to read from latch 0, we select device 0 with A0 being 0, and we set the RW bar now to 1, which means it's going to be a read from device 0. And the same for device 1. When we want to write to device 1, we set A0 to 1 and the RW bar to 0, which means we are writing to device 1, and that's why the enable 1 line is selected. And the same if we want to, similarly if you like to read from device 1, we select device 1 and we set our RW bar line to 1. So that means read from device 1, or read the contents of the latch at device 1. So what you have to do is to design this address decoder circuitry here based upon this table. So you need to get a Boolean expression for EN1, EN0, and using that Boolean expression then you use the NOR gate provided to design the circuitry. So you're only allowed to use a NOR gate to design the circuitry here. But the design principle is similar to what we would have done in class. So that's the circuit there. I've not included, I'm leaving the address decoder part blank. That's what you need to design. And this is the arrangement for the rest of the circuitry. We have our two latches. We have the 74157 quad 2-to-1 line multiplexer. And we have our switches here, which we're going to use to program each of the latches. So basically what we're doing is we are going to write 1001 to this latch, and we're going to write 0011 to the other latch, which is latch 1, and we want to be able to also read from both latches at different times. And this is the control circuitry that enables that to take place. So this is the circuit built up here. So what we're going to do is write to latch 0 the contents that you're given, which is 1001. So in order to do that, then we can see from the control table that A0 needs to be 0 and RW bar needs to be 0. So these are my two control lines here, A0 and RW bar. These are the 4 input switches, and these are the 4 output LEDs. This one being the LSB, and this one the MSB here. And the chips then, we have the 7475 there, that's the latch 0, and this is the other 7475, which is latch 1. This is the 74157, and this is the NOR gate for our address decoder. So, according to our table, to write to device 0, we need to set A0 to 0 and RW bar to 0, and we've done that there. So we are now enabling latch 0, which is this one here. So we're going to write the contents to that location, which is 1001. So I can set my switches to 1001 like this, and we can see immediately, because it's a transparent latch, we can see the contents displayed on the LEDs here, which matches the 4 switches. So now that I have written that to latch 0, I'm going to set my RW bar line to high, and if I make changes on the switches, you can see here on the LEDs that nothing changes. So it's now locked into latch 0. 1001 is locked into this device here. So now what I want to do is to program latch 1 to 0011, and in order to do that then I select set A0 to 1 and my RW bar line to 0. So it's 1, and then this one is going to be 0, and then I set this to 0011. And now I have programmed latch 1 to 0011. Okay, then when I have done that, the same as with latch 0, I can set my RW bar line to high, and now that locks in. You can see here that there is no change to the contents of latch 1. No matter what I do with the switches here, the contents of latch 1 are set to 0011. So if I want to read from, just to verify that latch 0 is still storing 1001, I simply just go select the other device. When A0 is 0, I'm setting A0 to 0. RW bar is 1, so that's reading according to the table here. It's 0, 1. So I'm reading from device 0, and you can see that it's still 1001, and that's correct. And if I want to read from device 1, I set my A0 line to high, and you can see that the contents of latch 1 is 0011, which is what we programmed it to be. So that is the experiment. The difficult part for you here is to design the address decoder circuitry for this control setup here. And the control is determined by table 1. And once you have that done, then it's just simply a matter of building the circuitry. The pins the pins for each of the devices are given here in blue. Okay, so that should make things a little bit easier for you. Okay, so that's experiment D3 part 2. a 2-word by 4-bit RAM module